What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.11 or 3.11, configure and verify manual and auto summarization with any routing protocol. This is a topic in the CCNP route exam code 300-101 version 2.0. Let's take a look at the exam blueprint, see where we came from and where we're headed. All right, this is the exam blueprint implementing Cisco IP routing, exam code 300-101. This is also known as the CCNP route exam. We just wrapped up the section configure and verify redistribution. We did that in two parts. We may or may not do this section, configure and verify manual and auto summarization, in two parts. We may or may not. I'll try to see if we can get this all in one. We just need to make sure we stay on topic. After this, we are going to move on, if we don't do a second part, to configure and verify policy-based routing, also known as PBR. So auto summarization, or just summarization in general, simply put, it's a way to combine a whole bunch of networks into one network statement, if that makes any sense. So it's kind of like, it's almost like an average number of IP addresses. That's the best way I can, put it. You got several different networks. You just combine them into one network statement to get there. That's simply put. Let's head over to take a look at what that is, the official definition. Okay, so route summarization, also known as route aggregation or supernetting, can reduce the number of routes that a router must maintain because it is a method of representing a series of network numbers in a single summary address. So if you take a look at this topology right here at the bottom, we have three networks on the left-hand side, right? Look over to the left-hand side with the clouds. You got 172.16.25 network, 16.26 network, 16.27.0 network, right? It's three different networks, right? And now router A, his routing table in the orange right there at the bottom, he's got those three separate networks listed in his routing table. However, when he advertises it, he can just compress it into one address. Now, why would we want to do that? We'll move on to the next slide now. We'll go on to that. Obviously, it's to make the routing table smaller. Nowadays, routers can, their CPUs and their memory can process, large routing tables, especially when it comes to the internet. BGP, if you've ever seen a BGP routing table on a production or an ISP router, those tables are long. You're sitting there space bar all day, and it's a long, it's a long routing table. Route summarization can minimize these routing tables. We'll do this in OSPF, EIGRP. We may brush up on it on BGP. I think I created a topology on that. So here's another example of summarization. Over here on the left-hand side, you've got four networks this time, 3 or 4 different clouds. You got the 16, I know it's kind of blurry, but if you just look real closely or somehow change the contrast on your monitor, you'll be able to see. But this was a great image, and I just had to take it. So shout out to Cisco.com. The IP addresses over the left-hand side, you got the 1612 network, 1613 network, 1415 network, right? Router D in the middle has his routing table there at the bottom, 1612, all separated, right? Separate networks and listed in his routing table. But if imagine he had like 30 routes to these networks, right? More networks, right? The routing table obviously will be this long, like super long. Route summarization can compress this, so that way it causes less utilization on the CPU and the memory when he advertises a summary address. Now, what we're going to have to do is we're going to have to do a little bit of computation or a little bit of math, not really math, but manual summarization by taking, we have to figure out a way to compress this address, these networks into one address. And it just takes a little bit of binary conversion to do that. I'll show y'all that next. Router E on the right-hand side will get this one address instead of 4 separate networks. Or if you got these 5 different cities you're trying to get to, you can just take this one road. That's probably the best way to, compare it to roads and highways. Y'all know how I like to do that. Step 1, convert the addresses to binary format and align them in a list. You look here on the left-hand side, we're taking this same exact topology and we're doing some manual summarization, right? We take the addresses, 1612 network, 1613, 14, 15, and then we have the 16. This is the last address in the network right here. And as you can see, we converted them into binary. Well, we didn't convert these into binary because we know it's going to be the same. This is 172 in binary. This is 16 in binary. And this is 11 in binary, right? No, that's not 11. This whole number is 11 in binary. What we're doing here is we're converting all of this. This is all 172, right? These numbers are all going to be the same, right? Same thing here. These numbers are all going to be the same. Now, this last octet right here is 11, but we just draw in a line, as you can see right there. Step 2, locate the bit where the common pattern of digits ends. Now, these are the common digits right here, right? It might be helpful to draw a vertical line, making the last matching bit in the common pattern, which would be this line right here. So all of these numbers, 172, 16 is the same in binary. Now this last one right here, it's this last octet, we split it right here because that's where the common bits ends, right? After that, they start changing. They're starting to be different. Now, the number of common bits is what we have to count to figure out what the subnet mask is. In this case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's going to be the subnet mask of our summary address. So /22, because we have 22 common bits. Now, how do we figure out the network address? That's where step 3 comes in. We've got 10 non-common bits right here, right? These are the ones that are not the same between all of these addresses in binary. Step 3, count the number of common bits, which we've done. The summary route number is represented by the first IP address in the block, followed by /, followed by the number of common bits. So the first IP address in the block is 172.16.12.0. So that's the first number in the block, right? And then we've already figured out what the number of common bits are. It's 22. So that's the network address. The summary address is going to be 172.16.12.0/22. That's the best summary route for this address. I don't know if I really explained that yet or really explained that really well, but we'll do another example for the GNS3 lab. So EIGRP summarization. Now each 3 routing protocols that we study for in the CCNP route exam, they all have their ways of entering the summary route in the CLI. Now computing them is the same though. Just, convert numbers into bits, find out how many of those bits are common, and then put a line on the after the most common bit, and then find out the first IP address that is in the network or in that network that you're trying to summarize, and then combine that with the number of bits. That'll give you your summary address. So that's all the same for all the routing protocols, right? Now just entering them into Cisco IOS, it's just the syntax is different. So summary routes in EIGRP are given a default AD of 5. EIGRP has auto summarization, as we know. That's why when you go into router and config mode and you're in EIGRP, it's best to do no auto summary so that way it doesn't summarize your addresses. The reason why you don't want to summarize all the time is because you may have discontiguous networks. If you know what that is, I'll leave a link in the description below, but it's basically like, if you look at this topology right here, you have these addresses, right? 16, 12.0, 13.0, 14.0, right? We got all these addresses here, but let's say we got a network that's all the way out somewhere in the left field that is like, say, the 16.0 network. It's somewhere out there. If you if you put a summary address sending it to that, it's not going to know how to get there. It just knows that to get to the 16 networks, the 16.0 networks, you got to go that way. But it doesn't know how to get to the 16.16. I don't know if that makes any sense. 172.16.16.0 networks. I'll put a link in the description below on what discontiguous networks are. You can turn off auto summary. We all know that. No auto summary. Manual summarization is enabled on the interface instead of the routing protocol using IP summary address. And then you put in the routing protocol, which is in this case is EIGRP, the network address, the one that you're summarizing. And you can modify the AD if you want to, but by default, it's given a number of 5. So let's go ahead and launch up GNS3 and do an EIGRP example. All right, so here's the topology. We got a simple topology. We got router 1 and router 2 in EIGRP ASN 1000. Right? We got router 1 that has all these loopbacks configured to them. We got a point-to-point network, serial interface in between the 2 routers. Router 2 doesn't know about these networks right here. Well, he will. We just need to try to summarize all these addresses, right? So here's our task. Like I said, we're going to have our tasks written down and then move on to them. Let's task number 1. First of all, let's start these routers up. calculate a summary address for router 1 to advertise. So let's go ahead. We'll have to do this by hand, and then we'll move on to the configuration. So we have a conversion chart right here. If you take a look at these addresses right here, if you want to pause it and think about what the summary address is, and then we'll move on to calculating them, and then we're going to move on back on to GNS3 and entering them. So go ahead and pause it right here. All right, we're back. Let's go ahead and summarize these. Remember, step 1, we have to convert these numbers in binary. Yes, y'all gonna have to watch me do this in binary. I'm not too great at binary, but let's go ahead and try to do this on video. So we've got the 10, 1. We know that all these networks have in common, just by looking at them, they're all in common, the 10, the 1, and the 1. So let's go ahead and convert those into binary. We know 10 in binary is, this is our conversion chart that we're going to use, right? It's 8 plus 2, right? So we know it's going to be quad 0 and then 0. No, my bad. We need the 8. So 1, 0, 1, 0. That's 10 in binary, right? They all have to be done with all these guys. Well, we can't make them all the same. So let's do this. Let's just copy and paste. All right, that's the first octet in binary. Next octet, we need to do 1 in binary. And then actually the next 2 is 1. So we know that in binary, 1 is quad 0, 3 zeros, and a 1. So we know that. Same thing here. 1, 2, 3, 4, 5, 6, 7, 1. We know that this is 1 in binary. That is 1 in binary, right? Y'all with me? So let's go ahead and copy those guys. Pretty sure there's an easier way to do this, but I didn't think about it. I didn't okay, so we know that these numbers are all unique, right? As far as the last octet goes, we know in binary 0, we all know that that's 0, right? All zeros, right? The next one we know is 10, 1, 1, 16. In 16 binary, we know that it's going to be 3 zeros, right? Just by looking at this chart, right? I'll probably leave a link in the description on how to convert numbers into binary. But if you were studying CCNP, you probably should know this anyway. 16 is 1. The rest are going to be zeros, right? We need to do 32 in binary. We know that is going to be 0, 0, 1, and then the rest zeros. We need to do 48 in binary. That's what, 32 plus 16, I believe. Yeah. So, yeah. 0, 0, and then the 32 is 1, and then the 16 is 1. The rest is zeros. We need to do 64 in binary. That's 0, 1, all zeros. We need to do 80 in binary. That's what, 64 plus 16, right? Yeah, 64 plus 16. So 0, 64, and then 0, and then 16, and then 0, 0, 0, 0. That's that in binary. We need 96 in binary. That's what? I believe 80 plus a 16. Yeah. So we need to do those 3 in 1. So then 128 is 0, 64 1, 32 1, 16 1, and then the rest zeros. And then we need to do, matter of fact, now that I think about this, there's an app that'll help you convert binary to decimal. I'll put a link in the description below. I have that on Android. God forbid if you have an iPhone, there's probably an app for that too. But that's how I learned how to convert decimal to binary. The last number is 112, so we need to do what? 64 plus 112, I believe. Let's see, 64 plus 32 is 96, right? I need to do a little bit of math here. 64 plus 32 plus, I guess, 16. Yeah, that's 112 right there. Oh, so I did that first one wrong. I did this one wrong. So here we need to go back to 96. So this is 0, 1, 1, 1. This one is actually, we don't need the 16 on that one. I mean, yeah. Do that one more time. So this one is right. We need to go back to the other one. We need to go back to this one right here. Right. So what was that? We need to do 96. What was that? 64 plus 32. That's 96. So this needed to be 0, 1, 1, and then 0. So that's the numbers in binary. So we know this right here in the red. We'll do a fill. we'll do a fill in this. We know those are the common bits. So we know that the summary address is going to be 10.1.1, right? This is the one that's going to be different. The common bits here, we got the 0, that's common. The rest moves on, right? So network address, so we know that this is going to be a line here. So then the one that's going to be the same is, we've got 6, 8, 16, 24, 25 bits. So we know that the subnet is going to be /25. /25 is going to be the subnet. Now we just need to figure out the subnet address. It's the first number in the block. So 10.1.1.0. That's going to be our subnet address, right? Again, I'll put a link in the description below on converting decimal to binary, as well as computing the summary address. So that should be our summary address, 10.110/25, right? Let's go ahead and move back on to GNS3. All right, so we calculated a summary address for router 1 to advertise to router 2. And then we're going to determine which interface and routing process the summary address should be applied to. So obviously the routing process is going to be EIGRP ASN 1000. We're going to configure the summary address on the appropriate interface. Well, there's only one interface that he's going to be advertising it from, so it's going to be this one right here, which is serial 00. First of all, let's go ahead and take a look at router 2's routing table. Let's go ahead and take a look at his routing table before we configure that address. Y'all remember what that address was, right? 10.110/25. So let's take a look at his routing table so far. Let me go ahead and reconnect to fix this. Show IP route. You got all these networks here, right? 10.110. That's all those networks that we just we had on our lists on our Excel spreadsheet. There they are, right there again. So again, the syntax, I know I didn't really go over it, but I had it in this last slide. If you remember it, pause and think about it. All right, we're back. So again, we want to go to the routing process, or the interface actually. You need to go to router 1 to do that. So we need to go to router 1, console into him, and we're going to configure the summary address. Real easy, y'all. We are in router 1. Configure terminal router EIGRP 1000, and then the no, it's by some, but it's not by routing process. It's you need to go to the interface. So in this case, interface serial 00, and then it's IP summary address EIGRP. Then you put in the routing process. In this case, 1000. You type in the network address with the summary address, which is going to be 10.1.1 or 10.1.1.0, and then it was /25. So in that case, it's 255.255.255, right? That's /24. Then we need one more bit, because remember the 25th bit was the one that was the last common bit. So in this case, it's 120.128. And then after that, I believe you can put the AD if you want to change it, or allow dynamic prefixes based on the leak map, which we are not going to do, none of these. So we'll just leave this as is. You remember what the default AD is for summary addresses, right? Pause it and think about it. We went ahead and entered that. Notice you'll see EIGRP resync. Let's go ahead and back to router 2 and take a look at his routing table now. So this was what it looked like before. Let's go ahead and take a look at it now. As you can see, we converted it into one summary address. I'm sorry, that's not it. What am I doing? This is the network address right here. This is the network address right here, 10.0/25. So next time he needs to send traffic down this way, he just needs to send it to the 10.110/25 network. Let's go ahead and ping one of these addresses just to be sure. Ping 10.1.1. What else was on here? I don't know what other what other addresses I have configured. There they go right there. 10.1.1.17. Let's do that. 17, and we got a reply. Let's move on to OSPF summarization, which is a little bit different. All right, so for OSPF summarization, there is no auto summarization in OSPF. You have to manually do it. You have to compute the address and then actually, compute the summary address and actually input it into Cisco iOS. EIGRP is done automatically for you. We just happen to turn it off with no auto summary. You can only perform this on ABRs and ASBRs. If you don't know what that is, an ABR is an area border router, and ASBR is an autonomous system boundary router. I'll show y'all the difference right now, actually, if you don't know the difference between those two. Take a look at this topology right here. We got this. I just realized this looked like Mickey Mouse right here. If you look at router 3 and router 4 right here, router 3 and router 4, if you notice, they are both in area 0, right? Router 3 is also in area 1. So he is on the border of two different areas. Therefore, he's an area border router, ABR. Router 3 is on the border of area 1 and area 0. Same thing with router 4. He's also an ABR because he's in two different areas. He's on the border of two different areas, area 2 and area 0, right? Router 2, however, is different. He is an ASBR because he is an autonomous system boundary router. He is in the autonomous system of a routing protocol, an OSPF routing protocol, but he's also on the boundary of the internet. This could have been another autonomous system, like say EIGRP. If it's the internet, it's obviously going to be BGP. That's the only routing protocol that's on the internet. But this could also have been an EIGRP domain. If this was also an OSPF domain, this would actually change his title to an ABR. I hope that makes sense to y'all. But he is an ASBR because he's on the border of two autonomous systems or two different routing protocols. That's why he's an ASBR. These guys are ABRs because they are on the border of two different areas of OSPF. Remember, EIGRP don't work with areas. It work with autonomous systems. So these are the commands. Same thing with OSPF. It's just two different commands. It's just written differently. You type in the area number, range, and then the summary address, and then the cost if you want to change that. This is almost kind of like changing the AD in EIGRP. For ASBRs, however, you must use this command, summary address, and then the network, and then the mask of the summary address that we computed. For this next one, let's go ahead and do some hands-on GNS3 OSPF. I am not going to convert to binary for y'all. I know I probably had some of y'all head spinning with that one. Maybe I had my head spinning with that one too. I know y'all seen the smoke coming out of my head trying to convert in binary. It used to be fun to me, but now I'm just like, man, let's just get to the configuration. All right, so if you take a look at this while this is loading up, we've got a couple tasks here. We got in the left-hand side area 15, right, with the north and the south router. On the right-hand side, we got area 0 with the headquarters router, right? We got area 1 sitting in between these two areas. Pop quiz for y'all. Pop quiz. Which one of these routers would be considered the ABR or SBR? If you know the answer to that, please put it in the comments below. We got, I'm probably going to give you the answer anyway, just by talking. Router 1 right here is in the middle of both these two areas right here. And we got a couple tasks right here at the bottom. Task number 1, view headquarters, routing table, and OSPF database. Let's go ahead and console in the headquarters. Let's take a look at his routing table. Show IP route. See, this is why we might have to do this. Let's go ahead and pause here. Okay, so task 1, view headquarters routing table and OSPF database. Let's go ahead and do that. Show IP route. He's got two routes here, right? Plus this directly connected network. The 10.0 network, which is this right here. We also got the 168.0.0 network, which is right here. And he also has a route to the 1.0 network, which is right here. Right? That's from the vantage point of headquarters router. Right? So, and notice that these are OSPF learned routes and they're intra-area, right? OSPF intra-area right here. OSPF intra-area. That's what these two types of routes are. AD is looking for those are going to be 110. Metric is 65. So let's go ahead and compute a summary route for router 1 to advertise headquarters, to headquarters. I already did that, so we ain't got to do no binary conversion like we did on the Excel spreadsheet. Let's go ahead and console into, determine which interface the summary route should be advertised. That's not what we do with OSPF. I put the wrong task there. When we go to router 1, when we go to the router and we need to summarize a route, an OSPF route, we go to the routing process and then put the summary address. So we go to router 1. Let's go ahead and console into router 1 and go to the routing process. So router, let's actually, we need to see what routing process we're running here. Do show IP protocol. We are running process number 1. And those are the areas, right? Area 15, we also got area 0 there. These are the routes we want to summarize right there. So what we need to do is go to router OSPF process number 1, and then the syntax for that is area, and then you put in the area number. So in this case, it's area 15. You put in a summary address. No, you put in the keyword range to summarize it, and then you put in the IP address, I believe. Yeah. So in this case, we're going to summarize this address and that address together. I'll tell you how to answer right now. It's 192.168.0.0 slash 1623 slash 23. So 192.168.0.0 slash 23. So it's 255.255.254.0. And then we could do advertise cost. We're not going to put any more other options on here. Let's leave that as is and take a look at router headquarters routing table now. This is what it looked like before. And now if we do a show IP route, you can see we combine those two into one address. Slash 23. 110.65. We forgot to look at the database too. Show IP OSPF database. And there is our summary route right there. Notice summary. This is a type, I believe, type 5 LSA, if I'm not mistaken. I'll have to double check. I'll figure it out and put it in the comments below. So yeah, that's OSPF summary route. Remember, there's 2 ways to enter a summary route. It just depends on whether it's an AS or an ASBR. You can look at this and tell what that is, right? I'm not going to give you the answer to that because that will be giving you the answer to the pop quiz. But again, those are the 2 different ways. We use this way. This is another way if you want to use on a different type of router. I'm not going to say what it is. As you can see, the answer is right there. Let's go ahead and move on to BGP summarization, route summarization. Okay, so BGP summarization is performed like this. You just type in aggregate address, prefix length, and then summary only. You do auto summary because remember, EIGRP is the only one that does auto summarization. We're not going to brush up too much on this because as I was doing research on this, I realized this is more of a CCIE topic. We don't want to do more than we need to as far as CCNP route goes. These are the basic commands for BGP summarization. So let's go ahead and launch up GNS3. I believe I created a small topology just to do a simple summarization for BGP. Okay, so here go our topology for BGP summarization. Again, I'm not going to compute this in binary for y'all. We'll just give y'all the answer. Take a look at this topology. We got router 1 sitting in ASN 500. We got a loopback. That's his loopback right there. Router 2 is in ASN 600. Router 3 is in ASN 700. We have all these loopbacks set up on router 3. That's going to be advertising to these guys right here. They're gonna have multiple ways to multiple entries for these loopbacks. Obviously, we want to combine them in one. So first thing we're gonna do is view the advertised BGP routes on router 2. Let's start these bad boys up. Console in the router 2. We are going to do. There's 2 ways with BGP though, right? We could do a show IP route. Obviously, we could also do a show IP BGP to look at the routing table. So show IP route, right? We got the 1 network and the 2 network. Apparently, we did not advertise the 13 loopbacks. Let's make sure we went into router 3 to do that. Let's console in the router 3. Make sure we are advertising those guys right there because they're not showing up in router 2, obviously. Let's while that's loading up, let's go ahead and look at his BGP table. Oh, that's why BGP wasn't up. That's why. Now let's go ahead and take a look at that. Show IP route. Nope, that's not the reason why. Let's take a look at router 3. They are neighbors now. So router 3 show IP route. Or actually, let's make interface brief. and exclude the unassigned to see what we got if those loopbacks are up. Those loopbacks are indeed up. They just not being advertised. Let's do a show run section BGP. Sorry for my typos, y'all. We are indeed advertising those routes. Let's take a look at router 2 to see why those are not showing up. Let's take a look at that one more time. Show IP route. There they go. I don't know. I guess BGP needed to kick in. There they go. All right. So notice these are BGP routes, right? B for BGP, right? The 13.1, those are loopbacks. Those are all on router 3. These guys right here. And we can get to them via quad 2, 2.2.2.2, which is this right here. That IP address right there. Let's look at the BGP table too. Router 2, show IP BGP. And those are those routes in the BGP table, routing table. Right? Let's dissect that real quick. The star means it's, I believe, no, it's valid. This is the greater than symbol means it is the best route to get there. Obviously, that's the network. That's the next hop, which is the local IP IP address on the other router, quad 2, which is that right there. That's that interface. To get to those loopbacks, take this interface. That's from router 2's perspective, right? Let me start wasting time and go ahead and configure that. Let's see, the task, computer summarized address for the loopbacks. I'll tell y'all right now, it is 13.0/22. I believe it was. Yeah, 13.0. It's a 13 network /23. Configure the summarized address on router 3. We need to configure that on here. Let's go to router 3 and configure that address. Y'all remember how to do it? Pause and think about it. All right, we back. Let me bring up the slides to show y'all how to do that. The syntax, remember, it's aggregate address, the prefix, length, summary only, and then auto summary. Configure terminal, aggregate. No, I believe we got to go to the router config mode. Router BGP, the process number again was not the process number, but the AS number is what we got to go to. So let's do this again now. Let's recap this again. In EIGRP, you go to the interface. In BGP and OSPF, you go to the routing process or AS number. Go to the routing process. So again, we go to router 3. Router BGP, he is in ASN 700. Aggregate address. The aggregate address is a 13.0.0. The subnet mask, aggregate mask will be it's /23, so 255, right? /23, 22. 255.255.252, right? Yeah, 252.0. And then we want to put in summary only. We don't want to do all these other options. Again, these are CCIE topics. Maybe when I start studying for that, we'll go further into that. But we're just doing summary only in this case. Other options, if you want to do all this other stuff, we don't want to do that. Then we're going to just do summary only. Auto summary. And let's go back to router 2 and take a look at this routing table in BGP table. That's how it looked like before. His routing table. This is how his BGP looked like before. Let's just do show IP routes. You can see now all of those addresses have been combined into this summary address. Right? That's the AD it's 20. 0 is the metric. It's via quad 2. Let's look at his BGP table. Show IP BGP. And they be combined into one. So, if you like this video, please comment, like, subscribe to the network.